Hello everyone, and welcome to another video in my channel. What value of P and Q such that the fourth root of P minus the fourth root of Q is equal to the integration from 0 to pi over 4 of the square root of 1 plus tan x all over 1 plus sine 2x. What do we need to solve this problem? We are required to find the values of P and Q, but we cannot do that if we don't find the value of x by solving this integration. So, to proceed, we need to ensure that the integrand is in terms of tan x. So to do that, let us first of all tackle the denominator. The denominator has sine 2x as part of it, and we can rewrite it as 2 sine x cos x, because if I have sine x plus x, which is sine 2x, I can write the equivalent as sine x cos x plus cos x sine x. And when I add the two of them together, I will have this. Now, I have to divide this one by 1 because this divided by 1 is still the same thing. Let us recall that in trig identity, we have sine squared x plus cos squared x is equal to 1. So this one will be rewritten as sine squared x plus cos squared x. So 2 sine x cos x all over 1 now becomes all over sine squared x plus cos squared x. Good. The next thing I need to do now is to divide both the numerator and denominator by cos squared x. So sine 2x is equal to 2 sine x cos x all over cos squared x divided by sine squared x plus cos squared x all over cos squared x, where this will cancel one of these, and then I need to turn this single fraction into two fractions. So I have 2 sine x all over cos x, because one has been cancelled, divided by sine squared x all over cos squared x, plus when I divide cos squared x by cos squared x, I'll have 1. Let's remember that the whole of it is the denominator. Therefore, sine 2x will now be equal to 2 tan x, because sine x over cos x is tan x, divided by tan squared x plus 1. So we have 2 tan x all over tan squared x plus 1. So the sine 2x will now be replaced with this. But we are going to make one substitution. That substitution is that we will let tan x equals to u, and then differentiate u with respect to x. So we have du dx equals to sec squared x. Also recall that sec squared x is equal to tan squared x plus 1. So let us make the x the subject here. Now dx will now be du all over, instead of writing sec squared x, I'll write tan squared x plus 1. Now let us remember that tan x is u. Therefore dx will now be equal to du over u squared plus 1. Now where I have my tan x, I'll put u there, and then rewrite this one as this, whereas our u is tan x. So writing this integrand, we'll have phi equals to the integration from 0 to pi over 4 of the square root of 1 plus u all over, now 1 plus this becomes 2u over u squared plus 1. Very good. Times dx is this, that is du over u squared plus 1. Now I'm going to leave off these parts until I find the value or evaluate this integrand, then I'll equate it to the right hand side. Let us simplify the denominator, which is 1 plus 2u over u squared plus 1. I will convert it into a single fraction. So we have u squared plus 1 plus 2u. I can factorize the numerator here as u plus 1 all squared. all over u squared plus 1. So I'll write this one in place of this in the denominator. So I have phi is equal to integration from 0 to pi over 4 of 1 plus u all over u plus 1 all squared over u squared plus 1 times du all over u squared plus 1. Now it becomes phi equals to integration from 0 to pi over 4 of 1 plus u all over, this will now go up, u plus 1 all squared times u squared plus 1 times du over u squared plus 1. Now this and this will cancel out. When that happens, we have a simplified integrand. So phi equals to the integration from 0 to pi over 4 of this becomes 1 plus u all raised to power 1 over 2 all over u plus 1 raised to power 2, then du. I can rewrite this applying the properties of exponent. So phi equals to integration from 0 to pi over 4 of 1 plus u raised to power 1 over 2 minus 2 du, which will be 0 to pi over 4 of 1 plus u raised to power minus 3 over 2 du. So we see I can integrate this easily, and I'll do the integration up here. And to integrate this, we have phi is equal to 1 plus u all raised to power minus 3 over 2 plus 1 over minus 3 over 2 plus 1, then from 0 to pi over 4, which will give us 1 plus u raised to power minus 1 over 2 all over minus 1 over 2 from 0 to pi over 4. So phi is equal to, this one will now go up. We now have minus 2 brackets 1 plus u minus 1 over 2 from 0 to pi over 4. Let us recall that u equals to tan x. So we now need to substitute tan x for u back. However, let us evaluate the boundaries. When u equals to 0, tan x, that is tan 0, is equal to 0. And when u equals to pi over 4, tan pi over 4 is equal to 1. So I will now write 1 for pi over 4 in place of u or tan x, and 0 for where I have the boundary as 0. So phi is equal to minus 2, 1 plus 1, that is for pi, minus 2, 1 plus 0. Let's remember minus 1 over 2 is the power. Now that becomes minus 2 brackets 2 to power minus 1 over 2, then minus, here becomes 1, then minus 2. When we evaluate this, we have minus 2 brackets 2 to power minus 1 over 2 here, then plus 2. So phi equals to, when we write this one, we have minus 2 over root 2 plus 2. Let us now convert it into a single fraction. The LCM is root 2. Root 2 divided by root 2 is 1. 1 times minus 2 is minus 2, plus root 2 divided by 1 is root 2, times 2 is 2 root 2. I also need to rationalize the denominator. So phi equals to minus 2 root 2 plus 2 times 2 is 4 all over 2. So we now have 2 as the common factor, then minus root 2 plus 2 divided by 2, where this and this will cancel out. And so phi is equal to 2 minus root 2. Now we can equate this value to the right hand side of the equation. All of these we have evaluated into this. So our 2 minus root 2 is equal to the fourth root of p minus the fourth root of q. We can square both sides to remove the square root signs. This is 4 minus 4 root 2 plus 2 is equal to root p plus root q minus 2 root pq. The fourth root, please. Now, I will add these two together. 4 plus 2 is 6. I will equate it to root p plus root q. And then square both sides. If I square both sides, I have 36 is equal to p plus q plus 2 root pq. Let's call this equation 1, equation I. Now, I'll also equate this term to this term. So I have minus 4 root 2 is equal to minus 2, the fourth root of pq. Square both sides. I have, first of all, this and this will cancel out, giving us 2 root 2 equals to the fourth root of pq. So we can square both sides now. And we square both sides. This is 4 times 2. And then this is root pq. 4 times 2 is 8. So root pq will give us 8. If we square both sides again, pq is equal to 64. Now, let us come to equation I. This is equation 1 properly. Let us come to equation I, where we have 36 is equal to p plus q plus 2 root pq. Let's remember that root pq is 4 times 2, which is 8. So 36 equals to p plus q plus 2 times 8. And 2 times 8 is 16. So p plus q is equal to 36 minus 16, which is 20. So p plus q is equal to 20. We now have our equation 2. Now, solving 1 and 2 simultaneously, we'll get that p is equal to 16 and q is equal to 4. Because 16 plus 4 will give us 20, and 16 times 4 will give us 64. Therefore, p, q is equal to 16, 4. Please like this video if you find it interesting. Subscribe to my channel if I haven't done so, and share this video to your loved ones. I would also like to read your comments in the comment section, particularly about the method you use in solving this problem. You can try the problem and then come back to tell me how or which method you use in solving it. Bye for now, and see you in another video.